expression in the limit approaches the integral of delta of x, y, z multiplied by z squared plus y squared dz, dy, dx. And it looks like I didn't leave myself enough room after all. We know the volume integral is going to be dz, dy, dx. And the limits on the integral, which I'll have to write with a finer point. For the sphere that we've been talking about, we go from 0 to 1, 0 to the square root of 1 minus x squared, and 1 minus the square root of 1 minus x squared minus y squared, to 1 plus the square root of 1 minus x squared minus y squared. For the specific density function that we used on this integral, and we'll start out over here, we go from 0 to 1, 0 to the square root of 1 minus x squared, and 1 minus the square root of 1 minus x squared minus y squared, to 1 plus square root of 1 minus x squared minus y squared. Density function 1 plus y. Distance from the axis of rotation, the x-axis being z squared plus y squared, and then it's dz, dy, dx. Now I'm going to leave it to you to think about how we can do this integral. I'm simply going to point out that we have z squared with respect to z, which is going to give us a z cubed over 3, which means we're going to have to cube this expression and cube this expression. That's probably going to be a little bit challenging. Well, not exactly challenging, but at least a little bit messy. And when we get to the y integral, you see that we're going to have a y squared and a y cubed from this expression, and we're also going to have some powers of y from this expression. So it's going to get a little bit involved, not something you'd necessarily even want to work through step by step, but you should be aware of the techniques that you're going to run into. So just a couple of brief notes about what is going to happen with this integral. First place, we have the binomial expansion a plus b to the n. Apply that to a plus b cubed, and we get a cubed plus 3a squared b plus 3a b squared plus b cubed. If a equals 1 and b equals square root of 1 minus x squared minus y squared, and that could be either plus or minus depending on whether we're doing the lower or the upper integral. We get a cubed, which is 1, and as we've seen, we're going to get a 1 for this and a 1 for this, so that when we subtract our lower limit from our upper limit, that's going to give us 0. That's going to go away. And then we're going to have plus 3a squared. Well, that's 3 times b. Now b is either plus this or minus this, depending on whether you have the upper or lower integral. And it looks like I wrote my x as a y here. Okay. And then it's going to be plus 3a, just 3, times b squared, and that's going to be times 1 minus y squared minus x squared. Now again, since the b is squared, the plus or minus doesn't matter, and what we get at the lower limit will be subtracted from what we get at the upper limit. We're going to get 0 for that. But then we have plus b cubed, and that's going to be plus our good old friend 1 minus y squared minus x squared to the 3/2. And that's going to be, we have a plus or minus, and since this is cubed, that plus or minus is going to follow us along, so this will actually be a plus or minus. It'll be minus on the lower limit, plus on the upper limit, so that when they're subtracted, this term and this term are going to reinforce each other, this term and this term are going to go away. So that our upper limit minus our lower limit on integration of just plain old z is going to give us 6 times this square root plus 2 times this 3/2 power. Now notice that we've got a z to integrate. 1 times y squared just gives us y squared, so one part of our integral, actually the 1 plus y times the y squared, is all with just respect to z, so that part can factor out of the integral. But we're going to have a 1 plus y times z squared to integrate as well. So we're going to be evaluating, well, that's where we're going to be evaluating the cube of this integral, rather the cube of this expression. So I do recommend that you try to find time to play around with this integral, see if you can get a reasonable result. Recalling that the mass of the entire object was, I believe, and you can check this out, 11 pi over 24. Its radius is 1. I take it back. The maximum that r can be for this object is 2. Remember that we have a sphere of radius 1 centered at z equals 1, so that the x-axis goes from z equals 0 up to z equals 2, so that the integral of mr squared has to be less than m times r squared, which is equal to, well, r squared is 4, and 4 times this is 44 pi over 24. This can, of course, be reduced to 22 pi over 11, over 12, which is 11 pi over 6, sorry, which is in the ballpark of 5. Most of the mass is concentrated a lot closer than 2 units from the x-axis, so that our moment of inertia will be considerably less than 5. I would say around between 1 and 2, 1.5 and 2, but that's just a ballpark intuitive guess. Again, now we're simply adding up all the mr squareds for our sphere in the portion of the sphere in the first quadrant with density function 1 plus y.